Okay, today we are going to talk about the input to our design, the input to our solar system design, which is the load. We want to design a solar system to meet our load requirements, or put in a different way, we want our solar system to power a list of appliances that we have in our homes, in our companies. Right. To start with, you have to understand what you have in your house. You have to understand what kind of load: fridges, lights, television sets, and pumps. Now, what is critical is to understand that there is two components in this design. There is energy requirements and there is power demand. You need to add all the watts, the total wattage of your load. This will determine the inverter capacity, because ultimately it is the inverter that is supposed to give you that power. Now, there are two types of loads. There is static load and there's dynamic load. Static load doesn't change over time. Dynamic load, it does vary with the time. For example, you've got a fridge, you've got a pump. These loads are dynamic loads, they change. When you switch them on, the power that they demand is huge. It's in the tune of 3 times the power that when they are running statically, or when they are running steadily. Therefore, knowledge of this is important, because ultimately you would want your inverter to be able to supply this surge power requirements. Now, static load is simple. You just add the watts. If you go to your appliances, usually the back, you will see a nameplate. Read that nameplate and see the wattage of your appliances. Some manufacturers, they don't put wattage, but they would give you current and voltage. So power is just voltage times current. So you multiply that, and then you make a list of the appliances. You've got how many lights, you've got how many TVs, how many fridges, how many pumps. After doing that, from the batteries, you want them to be able to sustain the duration of your operation, the duration when the light is on. So, the best way is to list the appliances: 10 lights, 10 TVs, for example, 10 pumps, and then after that, you go and list the number of hours that you think these items will be on. This is done so that at the end of the day, we get the total energy requirements per day. Power times time gives us energy requirements. So if, for example, security lights, they are usually on throughout the night, but inside lights, they are usually on probably just before people go to sleep. So these lights, they are going to demand energy differently. For example, another example is also a fridge will be on 24 hours, but it will cut in and cut out depending on the requirements of the cooling that is required. A television set is not going to be on throughout the day. It's going to be on possibly when the kids are watching their cartoons, and when parents are watching their news and some movies. So you will need exactly the number of hours that each item is going to be on. Having done that, you then add the total energy requirements of the appliances. When you do that, this will help you to determine now the number of solar panels that you need to sustain that energy requirements, and also the battery bank that you would require to sustain the energy requirements. In addition to knowing about your load characteristics or your number of appliances and their energy requirements, you would also need now to determine the reliability levels of your system. How do you want your system to behave, or how do you want it to sustain you? Is it totally an off-grid system and you would want power throughout the day and night? Is it a system that is connected to the grid and you'd want power up to when the mains power comes back? That is you that should determine that. And the guidelines for you to determine that is, when you want your system to be 100% reliable in terms of an off-grid system where completely there is no power, you have to design your system based on the least radiation month. In general, you have to design your system based on the winter radiation characteristics, because this is when we got the least radiation, such that whenever winter comes, your supplies are going to be available throughout. In other words, this is the worst case scenario. Therefore, if you design your system based on winter characteristics, then in summer the system will be even better in terms of performance. So that is another point that you would need to consider. Are you designing your system to be 100% reliable, or you want it to meet specific load requirements? Knowledge of behavior of the pumps will help you to determine the size of the inverter that you would want to get, so that it supplies that surge. The moment when you switch on a fridge, the moment when you switch on the pump, the amount of power that it takes will be probably 3 times the continuous running power. Therefore, this knowledge of your load is of paramount importance in as far as the system design and the system sizing is concerned. So for today, we'll end here, just knowledge about your load, and then next videos we'll be doing the sizing of the solar panels and the inverter and the battery bank. Thank you for watching, and don't forget to subscribe and press the like button. Thank you very much. Till we meet next time.